you spend nearly $1,000 on a processor alone, you want to make sure you utilize every last cycle out of that bad boy. In this video, I'm going to show you all the facets of maximizing every last ounce of performance from the Intel Core 2 Duo Extreme. First, let's start with overclocking. As previously covered, the Gigabyte DS3 has a whole multitude of options for overclocking. To begin with, we're going to use the unlocked multiplier and set it to 12. She boots into Windows without a hitch. Let's keep going and set the multiplier to 13. Once again, no issues booting Windows. We are currently at 3.46 GHz without a voltage increase. That's a 525 MHz improvement over stock. Of course, none of this means we're stable. I like to see what the limit is before Windows won't boot, and then I bring the CPU back down one notch to test stability. Stability was tested by running 3D Mark 06, SuperPi, and Orthos, a modification for Prime 95 that utilizes dual-core setups without having to run multiple instances. Let's try 14. No joy. Even with the voltage as high as 1.5 volts, the system will not post or boot into Windows. Next, let's start bumping the front side bus. Already at 275 MHz, it appears we've hit the wall. Through testing, I was able to achieve a maximum CPU speed of 3.57 GHz. For you kids at home keeping score, that's an increase of 22%, or 640 MHz over stock. The multiplier was set to 13 and front side bus to 275 MHz, with a voltage of 1.425 for the CPU. The memory multiplier was set to 3.33 for a memory speed of 916 MHz. And this chip easily wants to go higher. In fact, the only thing holding this CPU back was lack of better cooling. The Blue Orb 2, for all its fancy features like the blue color, ooh, and blue LED, oh, and, well, I'm sure there's something else special about it, didn't cool much better than the stock heatsink. Throughout testing, there was only a maximum temperature decrease of 5 to 6 degrees over the stock heatsink idle, and there was hardly a notable difference under full load. You can get a superior heatsink from Thermaride or Cooler Master, which could easily provide a higher overclock. It's time for video testing. The 7600 GT, while not a bad mid to low range card, is woefully underpowered when paired with the X6800. As the performance numbers show, the 7600 GT acts as a major bottleneck in the system, preventing the Core 2 Extreme from performing at its best. We used an 8800 GTS 640 to demonstrate the difference. In company of heroes, the performance increase was greater than an average of 40 frames per second, from 26.5 to almost 70 frames per second. In 3D Mark 06, it was even greater. Going from the 7600 GT to the 8800 resulted in an increase of 5,880 3D marks, or 174%. The 7600 GT doesn't compare. It doesn't even rank, and to be honest, it's not even playing the same game. For its time, it was a good solid card, but in today's world, to unlock the full potential of the X6800, you're gonna need something with a little more power. Of course, if you have the cool grand to spend on a processor alone, then chances are you can buy an 8800 GTX with whatever spare change you find in your couch cushions. So what did we learn? Well, to get the most out of the Extreme 2, first plan on overclocking. Intel obviously designed these chips for insane overclocks. They wouldn't be the flagship Intel processors if they didn't. To get the highest overclock possible, you're gonna need 4 key items. A quality motherboard with loads of BIOS options, a stable and efficient power supply, high quality memory, and a good aftermarket CPU cooler. These 4 items will allow anyone to unlock the hidden potential in every Core 2 Duo Extreme. But that's not all. Being able to complete Super Pi faster than anyone else is a neat feature, but it's not the reason people spend $1,000 on CPUs. It's about gaming and having the best frame rates possible. And to do that, you need a good video card. A chain is only as strong as its weakest link, and a gaming rig follows the same stupid, boring cliche. If you have any slow components in a PC, they're going to act as a bottleneck, preventing the faster devices from performing to their full potential. In short, it doesn't pay to be cheap.